This is the 24 hours of Nelson Ledges in Ohio, Ford's idea of the ultimate test track, where wheel-to-wheel competition confirms design concepts. Ford is out to prove that the statement, "Quality is job one," is not just a slogan. As an example, the EXP and LN7 you see in this race for front-wheel drive cars use regular production manual transaxles. The transaxle is designed and built tough enough to endure 24 hours of continuous hard shifting, the kind of quality that race drivers and customers alike appreciate. Ultimately, of course, customer satisfaction is what this is all about. Cars in the race scenes are equipped with the manual 4-speed transaxle, and it will continue to be standard equipment in 1983. The new 5-speed version will be optional on 1983 models. Both are completely metric, and the two are very similar in design, manufacture, and quality. To help you service 1983 cars, this video disc explains overhaul procedures for the new manual 5-speed transaxle. The first segment covers design highlights and comparison with the manual 4-speed transaxle.
To maintain these high standards of quality, it's most important that technicians service the new manual 5-speed transaxle with skill and knowledge to achieve high levels of customer satisfaction. Ken May is going to assist in demonstrating key service procedures. He'll be using this manual 5-speed transaxle flip chart as a guide, which you should also refer to for complete step-by-step disassembly and assembly procedures. But first, let's compare the 4-speed with the 5-speed to learn what's new and what's essentially the same. The major difference is the addition of this 5th gear and shaft assembly. We'll be looking at it in detail later. Other than that, the gear trains are very similar. However, none of the parts interchange. The case halves have been redesigned with additional bearing cups for the 5th gear shaft and with an additional funnel which functions as an internal oil pump for lubrication. And the 5-speed case halves are retained with 15 bolts instead of the 14 used on the 4-speed. Also, there are minor revisions in the clutch housing relating to the shift mechanism. Note that 2 gears are in constant mesh with the differential final drive gear, the main shaft pinion gear, and the 5th gear shaft pinion gear. Here is the most important difference from a service standpoint. All bearings on the 4-speed are press fit on the shaft. On the 5-speed, the bearings for the main shaft and 5th gear shaft facing the transmission case are slip fit. These slip fit bearings make it much easier to service the main shaft and 5th gear shaft. All other shaft bearings are press fit. Here's a minor but important difference that affects overhaul. On the 4-speed, the shift lever is retained to the shaft with an Allen set screw. On the 5-speed, a roll pin is used to retain the shift lever shaft to the case. With the addition of a 5th gear, there are, as you would expect, changes in the shift mechanism. On the 1982 4-speed, an external crossover spring is used to assist in shifting between 2nd and 3rd gears. The external spring is not used on the 5-speed. Instead, a 3/4 bias spring is located between the shift lever and shift lever shaft. 5th gear is operated by a lever that pivots in the middle of the reverse idler shaft and is connected between the main shift control shaft and the 5th gear shift shaft assembly. The main shift control shaft assemblies are similar for the 2 transaxles. The shift lever and shaft assembly are different. We've already mentioned the 3/4 bias spring. Note that the 5-speed shift lever also contains a 5th reverse inhibitor ball and spring. In the 4-speed, this function was performed by the reverse inhibitor spring and plunger. Major differences exist in the differential. The 4-speed uses a 1-piece steel case. It can be disassembled without removing the final drive gear. The 5-speed uses a 2-piece aluminum case. To disassemble, the rivets that retain the final drive gear must be drilled out to separate the case halves. This will be covered in greater detail in segment 4. With that brief description of design differences, let's see how it affects power flow. Both 4-speed and 5-speed transaxles function essentially the same way, except for 5th gear. If you are not familiar with the 4-speed, push number 1 on the commander for a brief review of 4-speed power flow. If you do not want to see this review, push number 2 on your commander. To better illustrate power flow in 5th gear, we've moved the differential from its actual position. In 5th gear, the 5th synchronizer moves to the left and engages 5th gear to the 5th gear shaft. The engine drives the input cluster shaft, and its 4th gear turns the 5th gear and 5th gear shaft, whose drive pinion turns the final drive gear of the differential. All main shaft gears freewheel because both the 1-2 and 3-4 synchronizers are in neutral. Remember, the main shaft pinion gear is also in mesh with the final drive gear and turning. Let's talk tools for a minute. All these tools for the 4-speed are also used on the 5-speed. Now, a word or two about service. Shimming is identical for both transaxles. There is a minor difference in tool usage, which will be covered in segment 5. Lubrication is also unchanged. Type F fluid is used in production, and it can be used for service. Dexron can also be used for service. Diagnosis for the 2 transaxles is similar. Refer to the manual 5-speed transaxles operation and diagnosis handbook for complete details. Before we end this segment, let's stop for a quiz. This segment covers separating the case halves, removing the gears, and the complete teardown of the transmission case and the clutch housing case. We are not going to detail each and every step, but are simply going to explain the key points. There is little difference between the 4-speed and 5-speed, except those steps relating to 5th gear components. We're assuming the fluid has already been drained. After shifting into neutral, remove the reverse idler shaft retaining bolt. Next, loosen but do not remove the detent plunger screw.
If you do, the detent spring and plunger will fly out when the case halves are separated.
Remove the fork interlock sleeve retaining pin. Now, unscrew the drain plug. Remove the 15 bolts that retain the case halves together. And tap the case halves apart.
I'd like to caution everyone not to use a screwdriver, for this will damage the aluminum case housings.
Lift the transmission case from the clutch housing. Exercise care not to drop the bearing cups or shims. Remove the detent plunger retaining screw that was previously loosened. Then the plunger and spring with a pencil magnet. Then remove the case magnet. Remove the C-clip retainer. Then the fifth gear relay lever. Lift out the reverse gear and shaft from the case. Next, use a punch to drive the roll pin from the shift lever shaft. Use a screwdriver to move the shift lever shaft out of the case to expose the hole in the shaft.
Before removing the shaft, a rag should be placed over the hole in the shift lever to prevent the ball and spring from popping out.
Good point, Ken. Now I see you use a magnet to remove the ball and spring, exercising care not to drop either into the clutch housing. Next, remove the shift lever and 3/4 bias spring as an assembly. Remove the main shaft, input cluster shaft, and main shift control shaft assemblies as a unit, followed by the fifth gear shaft and fork assembly, and finally the differential assembly. For most service operations, this is as far as you need to go in disassembling the 5-speed transaxle. A complete teardown of the transmission case and clutch housing usually is only necessary if the case is damaged. Here is a brief rundown on what's involved. The backup lamp switch, reverse relay lever assembly can be removed with standard procedures. To remove the input shift shaft, position it in neutral. And remove the control selector plate. Drive out the roll pin through the shaft into the recess in the case. Remove the boot then with a drift, rotate the input shift shaft 90 degrees, depressing the detent plunger. Pull the input shift shaft from the case. Remove the selector plate arm assembly, the roll pin, and the detent plunger and spring. The main shaft and fifth gear funnels are easily removed from the clutch housing, as are the 3 slip-fit bearing cups. Be sure to label each to assure correct installation. The clutch housing seals and bearing cups can be removed as described in the flip chart. First, the input cluster shaft seal, next, the differential seal, and finally, the differential bearing cup. To remove the speedo gear, first loosen the retaining bolt. Then pry on the retainer by pushing the gear and retainer out from the bore. Now we turn our attention to the transmission case. The slip-fit bearing cups and shims are easily removed. Be sure to tag each cup for correct identification and to keep the shims with the proper bearing cups. The transmission case differential seal can be removed with a drift, as shown in the flip chart, and the bearing cup with a remover and press. Be sure to tag the cup and shim for correct identification when reassembling. That completes the teardown, and it's time for another short quiz. The Customer Service Information System is a new program providing owners and prospective owners information regarding extended warranty programs that are important to the vehicle's reliability or performance, and technical service bulletins, TSBs, information on engine or transmission repairs that cost $125 or more, or maintenance procedures that, if performed, could avoid a repair condition costing $125 or more. The Customer Service Information System is the result of an agreement between Ford Motor Company and the Federal Trade Commission following allegations of a secret warranty program on piston scuffing. Here's how the new disclosure program works. First, technical service bulletins for repairs that meet the requirements of the agreement are identified and rewritten in less technical language. Your original TSB number and date are included at the bottom of the customer bulletin page for reference. Second, extended warranty programs are published under the title Ford Paid Repair Programs After the Warranty. Third, all this information is placed along with an index in an organized notebook binder. A complete binder was recently sent to your dealership. We recommend that the binder be kept in the service department. Starting in mid-December 1980, customers were notified of the availability of this information in several ways. By an information letter to all 1979 and 1980 new car and light truck buyers, by display posters for display in the showroom and service cashier area, by advertisements in 6 national magazines, and by notices in owner publications, new car sales brochures, owner's guides, and warranty fax booklets. The notifications include toll-free phone numbers where owners can call to receive a subscription to the bulletins, or specific bulletins for their cars, an address where they can write for the information, and a referral to their Ford or Lincoln Mercury dealer who also has the information. We need your cooperation to help keep your customers informed. Here's how you can help. First, when your posters arrive, display them so all your customers can see them. Second, be familiar with the Customer Information System binder containing the customer TSBs and the notices of Ford Paid Repair Programs After the Warranty. Each has been indexed for easy reference. Third, if a customer requests information for a specific vehicle and provides you with the year, make, model, engine, and transmission, be prepared to duplicate copies, which you may charge for. Or refer the owners to the toll-free phone number and the Ford Customer Information mailing address. Your help in keeping the Customer Service Information System visible and available is one more way to improve customer satisfaction. In neutral, all synchronizer sleeves are centered and do not engage the gears to the main shaft or fifth gear shaft. The engine turns the input cluster shaft and the mating gears freewheel. Thus, there is no power flow to the differential. In first gear, the 1-2 synchronizer moves to the right and engages the first gear to the main shaft. Power flow is through the first gear on the input cluster shaft to the first gear on the main shaft, and then to the main shaft drive pinion, which turns the differential final drive gear. In second gear, the 1-2 synchronizer moves to the left and engages the second gear to the main shaft. Power flow is through the second gear on the input cluster shaft to the second gear on the main shaft, and then to the main shaft drive pinion and final drive gear of the differential. In third gear, the 3-4 synchronizer moves to the right and engages the third gear to the main shaft. Power flow is through third gear on the input cluster shaft to the third gear on the main shaft, and then to the main shaft drive pinion and final drive gear of the differential. In fourth gear, the 3-4 synchronizer moves to the left and engages the fourth gear to the main shaft. Power flow is through fourth gear on the input cluster shaft to the fourth gear on the main shaft, and then to the main shaft drive pinion and final drive gear of the differential. In reverse, the reverse sliding gear, which is part of the 1-2 synchronizer, is in the neutral position. The reverse idler gear is moved into mesh with both the reverse sliding gear and the reverse gear on the input cluster shaft. Power flow is through reverse gear of the input cluster shaft to the reverse idle gear, which changes the direction of rotation, and then to the reverse sliding gear. It is splined to the main shaft and turns the drive pinion and final drive gear of the differential.